Welcome to the first part of the Geometry Chapter 11 review. Since I am not at school today and home with a sick child, I wanted to get some of this written out for you so you guys could actually watch it during class. So there's going to be a few different videos. This first video that I'm going to put up is just for the first page, problems 1 through 6. So I'm going to go through this. Some of these, the answers are not clear how they want them. So I'll make it clearer on the test. For the first problem, for a circle with a radius of 5 feet, find the length of an arc S with a measure of 28 degrees. Okay, since they don't ask you to use 3.14 or use anything for an approximation for pi, we're going to do a simplest radical form, which would mean leaving it in terms of pi. The first thing we need to do is, because we're finding the length of an arc, we need to find the total circumference. If the radius is 5 feet, the entire diameter is 10, and the circumference is 10 pi. Couldn't get the symbols to work here, so you guys will have to deal with this. So we're going to set this up as a proportion. 28 degrees over 360 degrees in the entire circle equals x over 10 pi. When we cross multiply, we're going to get 360, and that should say 360x equals 280 pi. So we're going to set that up as 280 with the pi symbol divided by 360, and that simplifies to 7/9 pi. So to write this out here, the way your answer would actually look is like 7 over 9. And you can either put the pi symbol to the side here or on top here. Either of those would be correct. For problem number 2, the figure below represents an oval track. The round portions of the track are semicircles. What is the length of the track? Once again, they don't tell you what to use for pi, so we're just going to leave it in terms of pi. The radius is 6 feet. So 6 feet here and 6 feet here would mean this entire length, to get just the straightaway, you're going to do 106 minus 12, which is 94. There's two straightaways, this part here and this part here, so that becomes 188. So you have 188 on the straightaways. Now you're going to have two semicircles. So entire circle, you're going to find the circumference of that. Since the diameter is 12, the circumference is 12 times pi. So 188 minus, why does it say plus 2 pi? What did I type wrong here? The actual answer is 188 plus 12 pi. So I'm going to fix that. And you would actually have that written as, you would write 8, sorry, I'm doing this with my finger and a mouse pad, plus 12 pi. Yes, if you had 12 pi plus 188, that would be correct also. For the third problem, we're finding the distance a bicycle wheel travels, and they've told us to use 3.14 for pi. So first we need the circumference of the wheel. 53, which is the diameter, times pi. So 53 times 3.14 is 166.42. That wheel is going to travel around 18 times, so the total distance is 2,995.56. For number 4, this is just like problem number 1. Okay? And in this one, they actually tell you to leave it in terms of pi. So 24 is the central angle over 360 equals x, the arc length, over the circumference, which is 16 pi. When I cross multiply, 360 times x is 360x. 24 times 16 is 384 pi. So x equals, please understand what I wrote here, this is actually x equals 384 pi divided by 360. That simplifies to 16 pi over 15. So once again, your answer would look like this. 16 pi divided by 15. For problem number 5, you want to find the area of the shaded region. Now this one didn't say. I'm going to tell you on the test, I want you to round this to the 100th. So let's write that on here. Round to the 100th. Okay? So 72 is a central angle over 360. Now we're finding area, so x over the area of the total circle. 7 squared is 49 times pi. We're going to actually use the pi button, and we get 153.94. 72 times 153.94 is 11,083.54. That's going to equal 360x, and x is equal to 30.79. For problem number 6, we're asked to find the area of the shaded region expressed in terms of pi. So we're going to have to find the area of the sector, subtract the area of the triangle to get the area of the shaded region. Here's the answers for those. Let's go through how to do it. To find the area of the sector, that's the central angle of 60 over 360 equals the area of the sector compared with the area of the total circle. The area of the total circle is the radius squared, so 30 squared is 900 times pi. When we cross multiply, 60 to times 900 is 54,000, so 54,000 pi equals 360x. Divide 54,000 by 360, get 150 pi. So the area of the circle is, and we would write that, if you want to see how it's written in handwriting, obviously, we're talking about 150 pi. Now we need to find the area of this triangle. So this is a triangle with a central angle of 60 degrees. Okay, that means it's also going to be equilateral. So I'm going to break that triangle, and I'm going to break it into 2 because I need to draw a height. So the new base here is 15. The slant height is 30. This is a 30, 60, 90 degree triangle. The side opposite the 30 is 15. So x is equal 15. So to get the side opposite the 60, we take 15 and we multiply by radical 3. So that is 15 radical 3. Yes, that's going to look like 15 square root symbol with a 3. Now, to find the area, we can do 2 different things. We can do the base, which would be 30, times the height divided by 2. Or we can take, since I already have 15 here, we can already take half the base, which is 15, times 15 radical 3. So 15 times 15 is 225 radical 3. So the way we write that is 225 radical 3. So we're going to start with 150 pi. That's this. We're going to subtract 225 radical 3. They're not common terms, and they want to keep this in terms of pi. They want to keep this in radical form. So our answer literally is 150 pi minus 225 square root of 3. And those are your answers for problems 1 through 6.